Welcome to Modern Retrogramming with Plasma. This is part 2 of exploring LISP 1.5 with DRAWL, my implementation of LISP written in Plasma. We're going to start off showing some examples. The first here we call loop. This will demonstrate 3 different types of looping constructs available in LISP 1.5. The first is the traditional tail recursion using S expressions. The function will call itself with updated arguments. The next example will use the algol-like prog feature that will look more like a traditional programming environment with a sequence of statements to be executed in order. This has the implementation of if and go, which is a go-to statement, and then a return statement returning from the function with a value. Lastly, we have the later addition to Lisp using the for loop. This allows us to do a traditional for loop starting with an index variable, an initial value, using itself in this case, an increment, a test, and a list of statements to execute. Let's go ahead and run this example. And we'll see that there actually is a difference in performance between the traditional tail recursion, the programming implementation, and the for loop. Now you'll notice a few pauses as it executes. This is actually the garbage collector running in the background to recover some of our memory. Notice how much faster the for loop is than the previous two. We can do a for loop and say we do it longer than we expect. So instead of running it forever, we actually can use Control-C to break into a running program just like you can in BASIC. We can also enable tracing to watch the functions as they are called. This is very useful for debugging, especially with tail recursion. Here we'll do a short loop, but here we see the trace of the function call and the associated parameters and values that go along with that function. Very useful. Let's move on to our next example. This is going to first look at the source code, which uses the algol-like prog. And here we'll also look at the traditional conditional statement, but also with the newer if statement. So the if statement is a later addition to the LISP 1.5 environment. This is an if, then, else sequence. It can also be just a standard if statement. And the difference in the prog environment is the conditionals fall through, they don't return. So it looks, again, very much like a traditional programming language. We're very much showing the exact same implementation, one using the conditional, one using the if statement. They're exactly equivalent here. Let's go ahead and run this. And we'll load up our 2 versions of a length function. They're both equivalent, so it doesn't really matter which one we use. So for this, we're going to actually create a constant list called numList. And here we're just going to throw a sequence of kind of just numbers. I didn't really think too much about it. They're sort of random, just a sequence of numbers. But they're also a combination of integers and floating point. DRAWL supports 32-bit integers and 80-bit floating point numbers by way of the standard Apple numerics environment library. So we have this list of numbers, what to do with them. Well, if we wanted to do some sort of operation on them, we could write functions that take a list and do stuff with them, or we can actually prepend an operator to the list. In this case, we'll do min or max. However, that's not enough to get the list to be executed. For that, we use eval. With eval, we can pass a list to the LISP interpreter for execution. So in this case, we'll do a min of those following values. And indeed, it calculates the minimum value from that list. We can do the same thing with max. So this will save us a lot of effort in terms of trying to write additional functions. We can just prepend an operator to a list of data. Here is the ability to sum the numbers in the list. Well, if we combine this with our length function, we could actually calculate the average of this list. So we'll just use length I, and it returns us how many elements are in the list. Let's use the combination of these features to calculate the average of this list. Again, we'll evaluate the sum of these numbers and divide it by the length of the list. And we get, I add enough parentheses, our average. DRAWL is a REPL environment, so it will inform you if there's more parentheses it's expecting, which is kind of a thing with LISP. Let's look at our big example, low res. This is using a function as an argument to another function. We're calling it fn here. And this function will plot a function from -1 to +1 on the low-res graphics screen. Our function will output a value between -1 and 1, which will then be scaled to fit on the low-res graphics screen. Our first one here is returning a function to calculate sine, and using the function to do that. Our second one is using quote, the shorthand for quote. If we can expand that out, they look very similar. Function is a little more lispy in terms of it will use values and variables defined elsewhere. If we're having a very simple function that only uses its parameters, its arguments, then we can get away with quote with just a smidge faster than function. So in this case, they are equivalent. Let's go ahead and run this and see what we get on the screen. Now, DRAWL is named for a reason because it is a little slow. The first function plotted out here is sine, and it's a little slow, so we'll just kind of speed this up a little bit to get through to the end of the plotting. But we get one sine loop, and then we'll do the cosine real quick. A nice color so you can compare and contrast them. Now, we can go back to text mode by turning off our graphics mode. Now, we can play with some of these functions. Let's look at our plot cosine function. Let's kind of make a new constant called pi2, which will simply be pi times 2. Then we can create a new function definition that will basically be a modification of our plot cosine. We're going to call it plot cosine 2. And we'll use our Apple editing escape sequences to go up here, and we'll just sort of re-type this in just like we could in BASIC. And we're going to replace that pi with a pi2. And then we need to add a few more parentheses at the end. Now we have a new function that should give us twice the cosine as the first one. Let's pick a color to plot this in, and let's plot it. You see our frequency is twice that of the first regular cosine. Speed this up real quick. Here's the first cosine. So indeed, we can easily create new function definitions. Lastly, we're going to go review some of the bitwise operators that DRAWL provides for us. An improvement over the 16-bit integers you usually get in an 8-bit environment. So here we're just going to print our hexadecimal value. We precede it with a $sign. But it prints out in decimal. We can switch to printing out in hexadecimal mode with PR hex, and now our integers are output in full 32-bit hexadecimal glory. Let's look at some of our logic operations. Here's the logical shift. It will take a value and a shift count and shift left. If our shift count is negative, it will shift right. We also have an arithmetic shift operator that does the same thing, except it will replicate the sign bit if we shift to the right. I actually think I missed a 0 here, so let's do that again with a full value. All right, one more 0, and we'll shift that to the right by 2. Notice how it fills in the sign value so it stays negative. The logical shift operator just does a simple shift and drops the sign bit. We also have a rotate, which does exactly what you think. It will rotate around from left to right. And then we have a full complement of bitwise logic operators. Here's bit and, showing our two values being ANDed together. We'll just do a AND with a lower word of FFFF. We'll just keep doing that with these two values to show what the bit operators does. The OR simply ORs them together, and we'll do an XOR. And we'll wrap it up with the bitwise NOT, just a complement of the value. And these are the basic bitwise operators available to DRAWL and allow for some nice calculator-like tools. So kind of your HP 16C calculator for anybody who knows what that is. Anyway, that's a quick overview of some of the features available in DRAWL as LISP 1.5. I hope you got something out of it, and thanks for watching.